Hi guys, um, time for the second video for this week. I hope you enjoyed the first one. It's right here, and I'm gonna be uploading this one today, and I'm gonna send you, of course, a reminder for next week. For today, psychologically mediated heart rate variability during official competition, ambulatory ecological investigations of the heart rate deceleration response with implications for quantifying flow. So again, I've tried to combine a lot of information and explain some things, and hopefully you will enjoy this video, uh, and it will make you more interested towards sports neuroscience. And I do know that at least one group has a paper towards their final project that has to do with HRV. So let's go. Um, the basis of this chapter is what is in our title, Ambulatory Sports Psychophysiology. All right, and this is a great way to monitor that mind-body connection continuously. We like ambulatory sports psychophysiology because it provides a high degree of ecological validity. And I want to stay here for 1 second. We There's always a debate between the research in the lab and in the research outside in the field, right? When we talk about ecological validity, what we're trying to say is whatever we find can be used, can be extrapolated to real life and real game in our field conditions. So we are trying to do research during real competition or during circumstances that are very close to real competition because we want to take the data and use them in real life and figure out another way to affect uh, our, um, our effort to increase peak performance in our athletes, right? However, there's not a lot of research in our field that you can say that it has high degree of ecological validity. So in other words, most of our research is in the lab. Okay. Now let's talk a little bit about the, the research that we have here, and again I have my notes, which is pretty much um, the the comment that I put in the YouTube video, and this is pretty much uh, the basic information that you can read as you are listening or watching my video. Now, concerning a heart activity, the main lines of research, which we're going to explain in a little bit, has to do with um, cardiac activity and reaction time, especially HRD and HRA. We're going to explain all this in a second. And then we'll have PSD power spectral density analysis. That it's a little bit different. We think that HRV in this line of research is great because it gives us information about those mind-body interactions, and especially, as we'll see in a little bit, in relation to attention and cognitive activity. So what are we trying to say here? If there is a decreased heart rate, if there is a deceleration of the heart rate, that happens because there is an effect from the baroreceptors, right? And that releases the cortex, meaning that we can now take, there's less cognitive activity, and then we have more attention to spare in the outside environment. Okay, if there is HRA, so we have an acceleration, the heart rate increases. We have the opposite. via the receptors, they are stimulated, so we have more cortical activity and less attention. One way to think about it is that if I have more cortical activity, I just focus my attention in the inside. When I have less cortical activity, I'm trying to I'm focusing my attention on the environment, on the outside. Okay, so in a few words, in our field and in the way we're describing today, HRD is better than HRA, and we're going to use that in a sec. Again, however, we don't have psychologically mediated HRV studies during real competition. Now, let's talk about acceleration, deceleration, how it's happening. HRV, right? HRV will be a metric, a way to measure the net effect of the parasympathetic versus the sympathetic nerves or systems. We talked about the sympathetic and parasympathetic. You know, pretty much with the parasympathetic, we calm down, and sympathetic is the opposite. So when we are in a calm state, the parasympathetic is kind of leading, right? If something happens, sympathetic, through the sympathetic system getting more activated, parasympathetic system get more deactivated, our heart rate is going up, and so on and so forth, right? Do you remember that from class? I hope so. So one key point here that I want to say in this research is that when the sympathetic nerves are activated, so there is stimulation, we can see that delay in the heart rate. There's a delay of up to 5 seconds, which is huge, right? When there is a stimulation of the parasympathetic system, the response that we see in the heart rate is way, way faster. So I just want you to remember that we can see the stimulation of parasympathetic system way faster through HR than stimulation of the sympathetic. All right? All right, let's talk now about blood pressure. And a little bit again, let's go back to the baroreceptors. Blood pressure, as you understand, is critical, and we'll talk about that in many, many courses, and that has to do with our cardiovascular function, right? So the baroreceptors pretty much have a very big effect on blood pressure. Now, what does that mean? That means that if we combine the information that we know about the autonomic nervous system, sympathetic, parasympathetic, and the blood pressure, we come pretty much into the same conclusion that we came just investigating just ANS, that elevated heart rate and blood pressure will have more cortical activity and less attention. Decreased heart rate, decreased pressure, less cortical activity, more attention. Okay, that's critical in sport, right? Think. It's critical in sport and pretty much in any kind of performance. How can we measure HRV? How can we do that? We can do it through time and we can do it through frequency. And usually what we get, the most common way to do that is through a tachogram, right? And you can take that like usually from a doctor, and we talked in class about the R waves, right? The R waves in a cardiac cycle. So usually it's between R and R. So we can figure out there, we can measure that. Let's go a little bit into more detail. Time domain measures. So we take the single cardiac cycle, 1 beat, right? And we're measuring that IBI as an interbeat interval or variability. And those changes, if that RR, that's in milliseconds, goes down, what do we have? HRD. If that RR between 3-4 beats goes up, what do I have? HRA. Right? So I measure that, and it's either going to be HRD or HRA. That's it. Frequency now. Frequency we're going to do with PSD, and I mentioned it before. I'm going to explain it now. So now we measure the power of the heart through frequency, and we'll have low frequency, high frequency. High frequency, we say it's mainly based on parasympathetic system. Low frequency on both, have very low too, and we'll have different kind of frequencies. For us right now, we should know that there is a low to high frequency ratio, and based on that, we can investigate what is going on between the sympathetic and the parasympathetic system, which again has affects what? it's being affected through stress, it's being affected through emotions, right? And as we said before, that affects attention, right? And cognitive activity. So that has a limited research support, but how beneficial would it be if you could actually do that research, right? Just throwing some ideas out there. I don't want to go into detail. I threw three actually, seminal pieces of research. The first two are from Lacey and Lacey, and that have to do with the heart rate variability and reaction time. And the third one has to do with the mathematical quantification of those changes that we see through HRV. Now, in general, when we talk about HRD research, right, deceleration, we have those mechanistic and non-performance studies. Mechanistic studies in general have to do with the properties of a phenomenon of whatever we're investigating, right? And at the same time, they prove the existence of whatever we investigate, because pretty much they try to find of the components, for example, of something. Right? That would be a mechanistic research. The performance research, on the other hand, adds on that because it takes it into performance and trying to find if there is, within subjects, between subjects, variability, if whatever we're researching, in our case HRD, can distinguish between good and bad performance, because the mere fact that something exists doesn't mean that it's important enough or we should use it. So yes, it exists through the mechanistic studies, awesome. Let's take it in performance studies and see, can that distinguish what we're looking for or not? Because if not, then we shouldn't be using it. It's not that important, right? And from the mechanistic studies, what we do know, and there's a lot of information there, and we know that before a stimulus, before we react, we anticipate a stimulus, there is HRD. And it doesn't only happen in humans, it happens in many, many species. And that's kind of important if we take it into performance studies. Because now we know that not only it's a physiological response of many, many species, it reflects, as I write, individual differences in athletic ability. We've seen that in some sports that we have researched, the experts, right, have there are individual differences. So they have more HRD, more deceleration before the stimulus, which means what? Less cortical activity, which means what? More attention. So what would be cool is, how can we create an intervention to promote that HRD, right? We have a quarterback. She is ready to throw the ball. Can we, through an intervention, make those athletes take advantage of that HRD, take advantage of that lower activity of the cortical activity, take advantage of that now more ability to focus their attention on the environment outside. That's all for today, guys. Hope you enjoyed it. Always listen to some cool house music. Have a great Wednesday. I'll be sending you a reminder soon. In the meantime, lift intentionally, not habitually.